Hello friends, welcome to my channel Shopnail Facts Education and Art and Craft. Today I am going to this is the series of number system part 3. Today I am going to discuss with you all about the Seive of Eratosthenes, Coprimes, twin primes and prime triplets, and HCM and LCM. And if you have not seen my number system series of part 1 and part 2, I have given the link in the description below. So let's get started. Seive of Eratosthenes. Draw a graph like this and then write 1 to 100 like this. Then cross out 1, as I have said that 1 is neither prime nor composite number. Now take 2 and cross all the even numbers, as all the even numbers are divisible by 2. Now take 3 and cross out all the odd multiples of 3. Then take 5 and cross out all the odd multiples of 5 that end with 5. Then take 7 and cross out all the multiples of 7. Then take 11 and cross out all the multiples of 11 like this. After that, there are some numbers remaining. Let me list out them for you. So, the numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Okay? So, these all are prime numbers. Seive of Eratosthenes helps us to find prime numbers between 1 to 100, 1 to 200, 100 to 200, 900 to 1000 and even 1 to 1000. You can try it out if you want. Now, coprimes, twin primes and prime triplets. So, coprimes are a pair of numbers in which 1 is the common factor of the number. So, let's see all the examples in detail. I have given 4 and 5, 17 and 19, 13 and 30 and 9 and 16. So, let's see in detail. So, the first example is 4 and 5. So, let's see. The factors of 4 are 1, 2 and 4. Oh, I have forgot to tell you that every consecutive numbers are coprime numbers. And every two prime numbers are also coprime numbers. Okay, now let's continue. The factors of 5 are 1 and 5. So 4 and 5 are coprime numbers. As you can see, there are only one factor, that is 1, and no other factor is common. Let's see the next example. I have taken 17 and 19. Now the factors of 17 and 19 are 1 and 17 and 1 and 19. So as you can see, the common factor is 1. So 17 and 19 are coprimes. Now let's see the third example I have taken, that is 13 and 30. So the factors of 13 are 1 and 13, and the factors of 30 are 1, 2, 3, 5, 6, 10, 15 and 16. So as you can see, there are no other common factors other than 1. So 13 and 30 are coprimes. Now the next example, 9 and 16. Let's list out the factors of 9 and 16. The factors of 9 are 1, 3 and 9. And the factors of 16 are 1, 2, 4, 8 and 16. So as you can see, only 1 is the common factor here. So 9 and 16 are coprimes. So for your better understanding, you can take a screenshot of this also. Now let's see twin primes. Twin primes are a pair of prime numbers which has a difference of 2. So twin primes are a pair of prime numbers, but it has to be a difference of 2. Let's see some examples. 3 and 5. So 5 minus 3 gives 2. So it has a difference of 2. So these two are twin primes. 19 minus 17. These two has a difference of 2. That is 19 minus 17 gives 2. So these two are twin primes. 29 and 31. 31 minus 29 gives 2. So these two are twin primes. So the trick is that you need to, if you have given a two set of numbers, you need to first check if those two are prime numbers. Then you need to check if they have a difference of 2. If yes, then it is a twin prime number. If not, then it is not. Let's check for 41 and 43. Let me check for 41, as the factors of 41 is only 1 and 41, and factors of 43 are 1 and 43. So they are prime numbers. Now let me check the difference, if they have a difference of 2 or not. So 43 minus 41 gives 2. So yes, I can see that 43 minus 41 gives 2. So they have a difference of 2. So 43 and 41 have a difference of 2. So they are twin prime numbers. Now prime triplets. They are a set of just 3 consecutive prime numbers. That's it. There is no fixed number about the difference. So the consecutive prime numbers like 2, 3, 5, 61, 67 and 71. These are prime triplets. Remember the list of prime numbers I have given you in the slide of Seive of Eratosthenes. So these are the prime numbers, as you can see. Now let me give you some examples from here. 2, 3, 5, 3, 5, 7, 5, 7, 11, 7, 11, 13, 11, 13, 17, 13, 17, 19, and so on and so forth. Let me take 41, 43, 47, 73, 79 and 83, then 83, 89 and 97. So these are all prime triplets. You can also find other prime numbers. I have given that as a homework to you. Okay. Now let's look at HCF and LCM. HCF and LCM. Before I start HCF and LCM, let me ask you a question. Have you ever wondered why there is nothing called LCF and HCM? You need to think about it. I will tell you at the end of this video. Okay. So first let's see HCF. HCF is the highest common factor. So HCF is the highest common factor. H for highest, C for common, and F for factor. HCF is also called GCD, which means greatest common divisor. So G for greatest, C for common, and D for divisor. Let's take some examples of HCF. So let's take 6 and 12. Now 6 has factors of 1, 2, 3 and 6. 12 has a factor of 1, 2, 3, 6 and 12. Okay. So as you can see, 6 is the highest common factor here. There is another 2 common factors, that is 3 and 2 and even 1. So these are common factors that I have circled, and out of them 6 is the highest, as you can see. So HCF of 6 and 12 is 6. Now let me give you a bigger number. Let's say 21 and 36. Will you find their factors and find their HCF? No. You will do something like this. 21 and 36. Write 21, draw 2 L's like this and write 21 and 36. You know how to prime factorize? They are just simple. You need to just take the factor, prime factor. So I can see that this is divisible by 3. 3 7s are 21, and then 7 is divisible by 7. So these are prime factors. Now 36. First I have seen that they are divisible by 2. 2 1s are 2, 3 2 8s are 16. So it is divisible by 2. Then again it is divisible by 2. So it is 9. Okay. Now it is divisible by 3. 3 3s are 9. Now it is again divisible by 3. 3 1s are 3. So their prime factors. So let me take 36 as an example. Their prime factors are 2, into 2 into 3 into 3. Okay, so I hope that you have understood the concept of prime factorization. You can also draw a factor tree also, but that's not required here, so I am not explaining that. Now, to find their HCF, as you can see, here is 3 and here is 3. So, their HCF is 3. But you might be thinking that we should always get prime numbers when we find their HCF. No. Let me take another example. So, let's take 24 and 36. Sorry. Let's take 24 and 36. Now, draw two L's like this. Write 24 here and write 36 here. Now, prime factorize 24 and 36. So 2 12, 2 6 and 3 2. Sorry, I have given the 3 by mistake anyways. And 2 1. This is also a type of prime factorization only. But for simplicity, we are taking the smallest number first. Anyways, so 2 18. I have shown you the prime factorization of 36. So I am showing it quickly now. Okay. Now let's circle the common factors. I can see here a 2, here also a 2. Here I can see a 2. I can also see here a 2. Now 3 also here is common. So how do you find the HCF? Because there are many common prime factors, right? So you need to write like this. HCF is equal to 2. Take 1 2 from here. Then take another 2 from here. And then take a 3 from here. So that is 2 into 2 is 4. And 4 into 3 is 12. So their HCF, you will write therefore HCF is equal to 12. You might take a screenshot of this also for better understanding. So as I have said you, their HCF should not be always a prime number. It can be a composite number also, but all the prime numbers should be multiplied. So, and in fact, 2, 2 and 3, these all are prime factors of, how? Prime factors of 12. So let me prime factorize 12. 2 6 are 12 and 2 3s are 6 and 3 1. So as I have broken it down, how to now 3 2 and 2 I get, sorry, into. So as you can see here also 2 into 2 into 3 and here also 2 into 2 into 3. So which means our HCF is right. And the prime factors of 12 are 3 2 and 2. Okay. Now let's move on to the next. Okay. Now let's see LCM. LCM is the lowest common multiple. Remember that HCF is highest common factor and LCM is lowest common multiple. Now let's see the LCM. L for lowest, C for common and M for multiple. Let's see some examples of this. Now let me take some examples. 4 and 6. Let me list out the multiples of 4 here. Let me write 4, draw a line, and 6. 4 1s are 4, 4 2s are 8, 4 3s are 12, 4 4s are 16, 4 5s are 20, 4 6 are 24, and dot dot dot. Now 6. 6 1s are 6, 6 2s are 12, 6 3s are 18, 6 4s are 24, 6 5s are 30, and dot dot dot. As you can see, as you can see that 12 is the lowest common, and then the common factor is 24, and there are other common factors also, they will go on. So as you can see, the lowest common multiple is 12. So the LCM of 4 and 6 is 12. Now let's take another example. Let's take another example, 12 and 18. Will you list their multiples and find? No. So see this. You will draw an L like this and write here 12. Write also here 18. Now see. 2 6 are 12, 2 9 are 18. Now 2 3 are 6. And let me keep the 9 as it is. You need to keep the 9 as it is like this. Which are divisible by 2, you need to divide that, and which are not divisible by 2, you just leave it as it is like that. Now let's take 3, as there are none of the numbers divisible by 2. 3 1s are 3 and 3 3s are 9. And as there is another 3, so until you get 1 and 1, you need to continually divide it. It's kind of prime factorization only. Okay. Now let's find their LCM. How will you find it? LCM is 2 into 2 into 3 into 3. That is 4 into 9, which is 36. And the prime factors of 36 are also, as I have discussed, 2 2 3 3. You can again rewind the video and check that, or you could do it on pen and paper and check that. I am not saying it again. Let's take another example of LCM. Let's take 17 and 19. So when the two numbers given to you are prime numbers, then you don't need to find their LCM. Just multiply those two prime numbers and you will get the answer. I will show you the proof also. Okay. So the LCM of 17 and 19 is 17 into 19. So when we multiply 17 and 19, we get 323. So 17 into 19 is equal to 323, right? So LCM is equal to 323. Okay. Now let me show you the proof. 17 and 19. So the prime number I find first is 17. So let me divide it 1 and 19. Keep the 19 as it is, as 17 is not divisible by 19. Now 19. Write 1 and 1. Sorry. So you get 17 and 19. So LCM is equal to 17 into 19 again, which is equal to 323. So you see, this took a lot of time, and this is just a matter of seconds. Just 17 and 19 is 323. Just put it there and then it's done. Now remember, I have asked you a question in the beginning, that why is there nothing called LCF and HCM? Let's see. So LCF means lowest common factor and HCM means highest common multiple. So as I have said, that every number has a common factor, that is 1. So if you take any two number in this world, even infinity, then you will get their LCF as 1 only. Okay. If you take 3 and 2, their LCF is 1. If you take 99 and 1000, their LCF is 1. And if you take 10 lakh and 9999999 infinity times, then their factor is also 1, lowest common factor. So every number that you take, their LCF is 1. Now what about HCM then? I have said you that there are infinite number of numbers. Okay. So as there are infinite number of numbers, there are infinite number of HCF and HCM. So you can multiply all the numbers and go on and on and on. After that, it will take a lot of time. Even after one day, you will not able to find the HCM. HCM doesn't exist even. So that's why LCM and HCM doesn't make sense. So here we came to the end of this video. That will be all for today. But before that, I need to tell you something, that if you have any questions or doubts, you can ask me in the comment section below. So in the next video, I will discuss with you all about the next number system, that is integers. So here we came to the end of this video. That will be all for today. Thank you.